Here we're asked to evaluate the 6 trig functions of theta. So we're given a right triangle, and so that allows us to use the idea that sine is opposite over hypotenuse, this idea that cosine is opposite over adjacent, adjacent over hypotenuse, and that tangent is opposite over adjacent. So we'll go ahead and start by completing this triangle in terms of the side lengths, because we already know that according to Pythagorean theorem, a right triangle's sum of the sides squared is equal to the hypotenuse squared. So we know that 24 squared plus 18 squared is equal to, we'll call this x, and that's going to be x squared. So now we do some computations, but before we do that, we can do this all in one big shebang, and we'll just go ahead and take the square root of both sides, so that we get square root of 24 squared plus 18 squared equals x. So now we can come over to our TI 83 or 84, and we can go ahead and enter this in as second square root, and we'll do 24 squared plus 18 squared, close that parenthesis, and so we get that side should work out to be 30. So we know that 30 is equal to x. So x up here is equal to 30 exactly. Okay, well, we want to complete things, so we want to be able to find sine, cosine, tangent, secant, cosecant, and cotangent. So we know that sine theta is going to be the opposite over hypotenuse, which is 18 over 30. Now, I'm not going to reduce these. I trust that you can reduce them, but that's not really what's that important. We know that cosecant is just the reciprocal of sine, so that's going to be 30 over 18. And cosine theta is adjacent over hypotenuse, so that's going to be 24 over 30. And we know that secant of theta is the reciprocal of cosine, so 1 over cosine, which reduces to 30 over 24. And tangent is opposite over adjacent, so that's going to be 18 over 24. And so cotangent is the reciprocal of that, and that's going to be 24 over 18. And so we have answered all the questions.